Hey, hello everyone. Are you guys able to hear me?
Yes, sir.
No.
Yes.
So, yeah. So today, I'll just share my screen. I hope in the last session we have discussed some of the standard signal, right? I guess we have discussed the unit step. We have discussed the delta. Okay. So today we are going to discuss and just try to cover all the signals, like at least the basic standard signal that you go through: rectangular, triangular, ramp signal, exponential. We'll try to discuss today. I guess we have discussed unit step, we have discussed delta, right? Triangular ramp and signum function we'll discuss today. Okay, so you already know about the step function, right? Step function is represented in the form of AUT, right? And where you already know that if you are dealing with the unit step function, then the A will become 1, right? I hope this is clear to everyone, right? This much you already know. Okay, if you have been asked to plot u of minus t, how will you plot that?
Mirror image in y-axis.
Mirror image in y-axis. Okay, just give me 1 second. Hmm. And what about that ut? So ut you already know. Ut you represent in this way, right? Okay. And how do you represent u of minus t? This is u of minus t. If you are doing the summation, what will you get?
The straight line passing by
A
one.
constant function, right?
Yeah.
Yeah. So you'll be getting a constant function. This is pretty simple. Okay. Now is the case ut minus of minus ut. So here again the same thing. And then if you are doing some subtraction, what will you get? So here less than, where the t is less than 0, what will you get? You will be getting 0 of 0 minus
Minus.
1, right?
Minus
So you
one.
will be having minus 1, correct?
Yes, sir.
Now from t greater than 0, so you have 1 minus 0, so you'll be getting 1, correct? So how does this function represent? So have you heard about this function anytime? So t greater than,
Signum, I guess.
yeah, this is a signum function. Okay, so this is signum function where t, for t greater than 0 it is 1, and for t less than 0 it is minus 1, and for t equals to 0, from the Gibbs phenomena you can see that when, because you have minus 1 here and you have 1 here, so you take the average value wherever the function is not defined, you just take it 0 minus 0 plus and then take the average. That's a Gibbs phenomena. So from here you can get the t will be, at t equals to 0 the value will be 0. So this is what your signum function is. So in the form of ut also you can represent, and when we'll come across the signum function we'll go through this again. Now we come across the rect function. So this is the important function that will be keep on going, like dealing with the rect function and again and again. Okay, before that, if I want to say like, okay, I'll just try to give you an idea about something else also. Okay, so let's for example you have been given a function xt equals to ut plus of 2 of ut minus 2. How will you represent this? So you have ut and then you have 2 times u of t minus 2. What is this? Okay, so I'll just represent ut. Ut is simple. Now 2 times, so the magnitude will be twice, and the ut will get shifted to where? It will be right shift or right left shift?
Right shift.
Right shift, right, from 2. So each of the axis will get added with 2. So everything from 0 to infinite will get added to 2. So it will start from 2. Correct? So it will be somewhat like this function, right? Now if you'll add this 2, what will you get? From 0 to
From
2, what
x
is the
to
value?
2, 0 to 2, it
Correct.
will be 1, and then it will be 2.
Yeah.
Rest.
So from 0 to 2, it will be 1 because 1 plus 0. And then from 2, 1 plus 2. So it will be a jump. And then you will be having. So here it will be 1. and now it has got added 2, right? So it will be 3 here. Correct? So now what have you got an idea? So you'd have got an idea, right? So whenever you have been given the summation of the step function, right? So what will do, you'll start with there. So you'd start ut, right? So ut starts from where? T equals to 0, right? Because before 0, everything, so for all the function, you already know that the magnitude is 0. So write 0 plus whatever the number of function that you add, it will be 0 always. So now it starts with t equals to 0. So you can start directly. So without even doing this two step also, you can directly come to the final signal or the function. Okay, how can you do that? So what you'll have to check is, you'll have to see that what is the magnitude. So this magnitude you have to check. That magnitude will help you to add the value directly. Okay, so here you can see that from the starting the function was 0, because from minus infinite the function is defined from t equals to 0, right? So from minus infinite to 0 there is no value that you will be adding, right? Now there is a jump as t equals to 0, so you have made a jump. So from minus infinite you came like this, right? And then at t equals to 0 you saw that there is a magnitude of 1 been added, so you have added here, right? And then again you saw that there is a magnitude of 2 been added. So I told you, right, this is the magnitude and this is the value at which you'll have to take a jump. Okay, so you took a jump at t equals to 0 because the function started, right? So with the magnitude 1. Now the next step was at 2 equals to 2 you have to take a jump of 2, right? So now you have taken a jump of 2, so from 1 you went to 3. Is it clear to everyone?
Yes, sir.
Okay, now try to solve this one. So I have a question. 2 times u of t minus 2 minus u of t plus 1, then 3 times u of t minus 1. So the same thing. The magnitude is 2 at what time? This at t equals to, so sorry, I'll just write it. T equals to minus 2. This is at t equals to minus 1 and t equals to 1. So from minus infinite to minus 2, there won't be any magnitude. At minus 2, there will be a jump. And again, at minus 1, there will be a jump of minus 1. That will, the value will go down. And again, there will be a jump of 3 at t equals to 1. So how will you plot? So from minus infinite to minus 2, the value will be what?
0.
0. Correct? And at minus 2, there will be a jump of how much? 2.
2.
Correct? So 2. Now, and again at minus 1. So you can see that. So it will go till minus 1. It will be 2. Now at minus 1, what happened?
Minus
It will
1.
go down, right? So it will come here at 1. Correct? And it will go till 1. Till 1 it will go. Now at 3, there is a jump of 3, right? So here from 1 to 3, it will jump. So there will be 4. Is it clear to everyone? How do you plot this type of a function if you have just giving the summation of unit functions? Any doubt here as of now? Anyone?
No, sir.
No, right? Anybody else?
Sir,
Yeah.
suppose here it is t is equal to plus 1, then it will go left side over. This one,
Where?
middle one, t is equal to minus 1, right?
Huh?
If it is t is equal to plus 1, then
Here t equals to plus 1.
no, you're down one, you're written, right? T is equal to minus 1, right?
Because, okay, you are saying that if the function is
T minus 1.
this one, t plus 1.
Yeah.
No, the function, sorry, the function is t minus 1.
Yeah, t minus 1. So it will be t is equal to plus 1, right?
Then there also, this is t equals to plus 1. So there won't be any drop as such. There won't be any drop as such till t equals to 1.
Okay.
Okay, but you can see that minus 1 and plus 1, so both are same function, right? So you'll be left with 2 of u of t minus 1.
So
So
how will the graph appear, sir?
what will happen? Okay, so the graph will appear. So it will start from 2. So minus 2 it will start. The magnitude will be 2, right? So it will go
Yeah,
till
2.
where? Till t equals
Till
to
1.
1, because there is no break in between as such. So it will go till here,
So,
and at that point it
oh,
will add 2 magnitude, right? So it will add 2
okay, sir,
magnitude.
okay,
So
sir.
it will be 4.
Okay, sir, I understood.
Okay, good. Anyone has any doubt? No, right? Okay.
So can
So
you do
now
the
if I'm
previous one, right?
previous one, which one? This one?
No, sir. No, sir. There's a t is equal to -1. It was right. That question. This one.
Okay. So if you have t equals to t plus 1, that means there should be a break at t equals to -1. Now what will happen? You started with minus, like from minus infinite the value was 0 till there is a break at t equals to -2. So the magnitude of 2 got added. Now again there is a break at t equals to -1. So at t equals to -1 there should be a drop of one value, right? So at t equals to -1 there should be a drop of -1. Okay, so it came here. Now the next stop is at t equals to 1. So it will go till 1 with the value magnitude of 1, and again at t equals to 1 there is a gain of magnitude 3, so it will gain 3. So here it will be 4, 2, 1, 4. So it will go till infinite, because after that there is no break, so it will go keep on going there. Clear?
Yes, sir.
Okay. Now the next function, and this is how your rect function will be: minus of u of t minus 2. How will you represent this? It started from minus infinite till 0. There is no value that needs to be added, right? So it will be like this. At t equals to 0, one magnitude has been added, right? So 1 is been added, correct? And now again at t equals to 2. So t equals to 2. What happens? That one magnitude that has been added, now there should be a drop of one magnitude. So it will come down.
0.
Okay? So it will be 0. So this will be the function, right? This will
By
be the
default,
function.
if u of t is there, the starting point is 0 only, right?
Yeah, for ut you already know that ut is like, ut is defined as what? Ut is defined as t, for t greater than 0 the value is 1, for t less than 0 the value is 0. Okay, it's not defined at t equals to 0.
But
Normally
here
with the
it is
Gibbs
like
phenomenon we take
what I thought is your t is equal. Here it is not defined, right? T is equal to 0, right? So I thought.
t equals to 0, it's not defined. Okay, but normally we take the value as zero point 0.5 with the Gibbs phenomena. If you've heard of that, like normally if a value is not defined at that particular t, then you take t minus t plus and then divide with 2. So that will be the average value at t equals to 0. Okay, so that normally you take it as 0.5, but that you don't show
Initially,
here.
if only ut is defined. Hello?
Yeah, ut is defined like this only, right?
Okay, sir. Oh, no, no. My question is by default, if ut is given, if it is like you have to compare it with the ut minus 2. If it is less, then you have to come add 0, right?
Correct.
Okay, sir.
Huh. So this till now is clear to everyone. I don't think so there is any doubt. Let's come to the rectangular function then. See what happens in a rect function. Is a rectangular function. Okay. So this is how you define, like represent a rect function. This is what rect function. Have you heard of this? Gate. This is known as a gate function also. Okay. So this is the magnitude, right? So this is defined mathematically. I'll just write it as, I hope in the first week also it has been defined. Our prof also has just defined this rect function, right? So t is the independent variable. 2t is the width of this rectangle. No, sorry. So here the function. See, mistake. Hmm. This is how we define a rectangular function. Here, a is the magnitude for the rect function. Tau or t, what like the tau that you call it as. Tau is the what? The width of the rect function. Okay, so this is a form of a rectangular function. It will look like a rectangular function where the magnitude is a. Okay, t is the independent variable, the upper one. The tau is the width of the rectangle. Okay, and how do you define? So t from minus tau by 2 to tau by 2, the value will be a. Okay, and in other point, otherwise it will be 0. So how do you define this function? So the value from minus tau by 2 to tau by 2, the value will be what? A. The magnitude will be A. Okay, so you can see that the width is tau, so that is what represented here. Okay, and the numerator is the independent variable, and A is the magnitude. Okay, is it clear to everyone? What is the area for
Yes, sir.
this? What is the area? So some of the properties are what? First of all, the
Then
width is what? Width is tau. So whatever it has
C.
been
Tau into
represented,
A.
tau is the width. Okay, the area is what?
Tau A.
A tau. Okay, C. Correct. A tau is the area. Now, if you have been asked to represent, so this minus tau about 2, so how can you represent this in the form of the unit step function? We have already learned something, right? So you can represent this in this way, right? Now, how can you represent this function in the form of a unit step function? How will you, so from minus infinite to minus tau by 2, what happens? The values is 0, right? So you'll not do anything. Now at t equals to minus tau by 2, what happens? There's a gain of magnitude what? A, right? So what can you write? A times u of t plus tau by 2. Correct? And now what happens? At t equals to tau by 2, the value, the magnitude is reduced. So minus of a times u of t minus tau by 2. This is the function, right? This is the direct function. Are there? Are you able to understand this or not? Are you able to understand this?
Yes, sir.
Yes, sir.
No. Now, if I'm asking you, so this all, so and what happens when do you call it as a unit rect function? When this area a tau, whenever the a tau is equals to 0, right? That you call it as a unit rect function. Okay. So this depends on the area of a rect function. Now, if I have to represent this function, how will you represent? A times rect of 2t upon tau. So what we are doing here, we are just replacing t with 2t, and whenever we do t, we replace with t to 2t, what happens? Whether it will
1 by 2.
expand or compress,
Compress.
it will compress, right? Because all the axis will get divided with what? 2, right? Correct. And now you can just think in that way also. A times rect of t upon tau by 2. Okay, so tau by 2 is the width of the rectangular function, right? So if tau by 2 is the like the width, then it will be what? It will start from minus tau by 4 till tau by 4, and then the magnitude, because you know that this is the width, right? The denominator part is the width of the rectangular function. Okay, so tau by 4 and tau by 4, it will make tau by 2. Okay, and the magnitude will be A. Is it clear? Is it clear to everyone?
Yes, sir.
Okay. And now if you have a function a times rect of t by 2 tau, whether it's an expansion or a compression. So here the width is what? 2t. You can see that the width is what? 2t. Now if you have to represent this rect function, the magnitude will be a and the width will be what? 2 tau, right? So the width will start from minus tau to tau. Okay. Now this function has got expanded. Now you already know that we have changed from t to t by 2. If you are changing from t to t by 2, the axis will get multiplied with twice, right? So this is the expansion of the function. Clear? Now, if I'm asking you to represent this function 4 times rect of t by 5, can somebody tell me what is the width of this function?
5.
Width is 5, the magnitude is 4, right? So how will you represent this? Minus 5 by
From
2 to 5 by 2. Correct?
yes,
Clear?
sir.
Now I have to represent 5 of rect t minus 2. What is the width of this function? What is the width of this function?
1.
Yeah, width is 1. Okay, so how will you represent this function? So now let's, for example, you just write it as rector.
Right shifted and
Yeah,
from
correct. Yeah, so the function should be this should have been what the
3 by
yeah.
2
If you just have to
to
represent 5 rect t, then this is the magnitude minus 1 by 2 to plus 1 by 2. Now what you have to do? You have to add 2 all the places. Correct. So it will start from where 1.5. It will go till 2.5. Is it clear to everyone?
yes, sir.
The rect function is done, right? Any doubt? Anyone? We'll do some
Can you
operations
repeat that
also.
2t by t?
What happened?
Can you repeat that 2t by t, sir? A rec of
Okay.
2t by t. I just understand now.
Yeah. Okay. So what happens in 2t by 2t by tau? See, this is a rect function, right? A rect of 2t by tau. So what will happen? You can think in two ways, right? One way is to approach is you can just see that we are changing t to 2t, right? Whenever you are changing t to 2t, what you are doing? You are basically, if you are just converting t to, you already know that at, right, where a is greater than 1. What happens? You just divide all the values of axis with that a, right? That means what? If a
Yes, sir.
value is greater than 1, you just compress the function, right? So now
Yes, sir.
earlier it would have started from minus t by 2 to t by 2. Now you divide all the values with 2, right? So now it will start from minus t
Yes,
by
sir.
4 to t by 4. Okay,
Yes,
or
sir.
you can think in that way that this function you can just write it in this way: a of rect of t by tau by 2. This same, right? And you already know that denominator part represents the width of the rect function. If the width is tau by 2, then it should start from minus pi by 4 to pi by 4, because you already know that the rect function is symmetrical above the y-axis, right? So it should start from minus t tau by 4 to tau by 4. Clear?
Yes, sir.
Okay, so if it is clear, then move to the ramp function. What is the ramp function? Ramp or ramp signal. How do you represent? This is in the form of k of rt, right? So where the value is what? Kt for t greater than equals to 0, and t for t less than 0, this value is 0. Okay, so this is the slope of the function. K is the slope, right? So let's, for example, if you are taking k equals to 1, then it will become a unit ramp function on a unit ramp signal. Okay, for those cases the value will be what? T for t greater than equals to 0, and t for let will be 0. Okay, so till now what have we have discussed? We have discussed k of ut. This is a unit step, like a step function. Then delta, then you have ramp function, and then you have rect function. For this case, when k was equals to 0, okay, or you can say the magnitude, sorry, k was 1, magnitude of 1, then you have this unit step function. Here the k is 1 means what? Can somebody tell me? If the k is 1, that means what? The magnitude or the area? For a delta function, if k was 1, that means what? The area of the delta function is 1, right? And here also a tau equals to 1, then you call it as a unit rect function. Okay, so here the area should be equals to 1. Is it clear to everyone? Are there or not?
Yes, sir.
Yes, sir.
Okay. So now for the ramp function, this is how you represent the ramp function or the signal. This is pretty simple. Okay. Okay. So how do you represent this ramp function? So you already know that we have unit ramp function. This you represent in this way, t greater than 0 or t less than or equals to 0, wherever you take. So this is how you will represent the ramp function. Slope is equals to 1. Okay, if you have to represent 3RT, 3 times ramp function, how will you represent? This is what? This is 3t, t greater than equals to 0 and 0 otherwise. Now the same thing, the slope will change. So the slope will be what? 3. Okay, so here whenever represent this kt, this k represents your slope. Clear?
In ramp, it is always
Yes.
positive, right? Then
What?
in ramp,
Why it's
usually,
negative in
sometimes
No.
third
negative.
quadrant?
What? I didn't get.
In third quadrant, why it's there is graph like
No, it should not be.
Means it is always positive, right? If it is
Yeah. Mhm. If you have to represent minus of RT, this will be like this. Okay, slope is
no,
minus 1.
like it will
Okay,
be in
this
first
represents
and
the
fourth
slope.
quadrant only, right?
No, if you take it as r of minus t, then it will be like this, right?
Okay, sir. Okay, sir.
Okay.
Minus or of minus 8 filter.
Huh. You got it right. Now,
Yes, sir. Yes, sir.
oh, if you have been given r of t minus 2, so this is pretty simple, right? You just start with t equals to 2, right? Slope will be equals to 1 only. Now, let's for example, you have a function something like this, 3 times r of t plus 3. What will happen in this case? It will start from minus 3. What will be the slope of this function?
3. 3t.
3.
Yeah, the slope, correct. The slope will be 3. Okay. Okay. So the similar fashion, if you have to write this rect function, sorry, not rect function, the ramp function in the form of a unit step function, how will you write this? Can you write this? T times u of t. Is it same or not?
Yes, sir. Same.
They are same, right? Let's for example, you take a t function, so that will be minus infinite to infinite will be defined. Now you multiply with this unit step function that is defined from 0 to infinite only. So this will get cancelled. So you'll be left with what? Ramp function. Correct? Correct or not?
Correct, sir.
Oh. See, whenever you have been said about to t minus 1, how will you write this in the form of a unit step function? This function is what? This will start from t equals to 1.
T
How
is
can
equal
you
to
write
1.
this in the form of a unit step? So you'll represent this in t minus 1 times u of t minus 1. Okay. So this will tell you the point from where it should start, point
It will shift
where
the
it will
x-axis
start,
from x-axis will take.
and this is the equation of the line. If you are writing in the form of a ut, okay, okay, is this clear or not to everyone? How did you like? How can we write the like the ramp function in the form of a unit step function?
Yes, sir.
No or yes, maybe
Sir, can you
okay.
plot this graph for this
See,
one?
how did you wrote? Yeah,
t minus
this
1 u
graph.
of t minus 1 no no this one u t minus 1
Okay.
u minus t minus 1. So graph will be like the
Okay.
t, it will shift from x-axis one something.
Yeah. See, t minus one will be what? T minus one will be something like that. Correct. Now you are
Oh yes sir, yes
multiplying
sir.
with what? So you are multiplying with this function u of t minus 1. So everything else till before this will be 0 and will start from here only. Correct?
Okay.
Hmm. If you have to, if we have to plot this function t minus 2 u of t minus 2, how will you plot this?
Start from the 2.
Yeah, it will start from 2. The equation will be t minus 2, right? The equation of the line is t minus 2. That means the slope is 1 only, right? So this is t minus 2. It will start from t equals to 2. Clear? Clear with everyone? Yeah. Now
Yes sir.
Yes, sir.
I have to draw. Okay. So if I have to draw xt equals to r of t plus r of t minus 2. So when the function was ut plus u of t minus 2. So what we used to do, we used to take care of the magnitude. So whatever the magnitude was there. So let's for example this is x1. How will you plot this x1? You already know that it will start from minus infinite to 0. It will be 0. At t equals to 0, it gained one magnitude, right? Until t equals to, so t equals to 0, then t equals to 2. So at t equals to 0, it gained a magnitude of 1, right? And then at t equals to 2, it has gained a magnitude of 1 again, right? So it will again be like this. So it will be 2. Correct? This is x1. Now, in similar fashion, whenever you deal with a ramp function, what does this mean? This value 1, what does this mean? This is a slope, right? Correct?
Yes, sir.
Correct? Is everyone fine with this? No. So whenever you write a ramp function, you represent, I told you, right? In a ramp function, whenever you write a ramp function, where is that? Yeah. So whenever you write 3 times RT, so this is what? 3t. So 3 generally kt is the ramp function. So k denotes the slope of that function, right? So in the similar way, whenever you have to plot this function xt equals to rt plus r of t minus 2. Correct? So here the slope is 1. Here again the slope is 1. So I'll start with t equals to 0. So till from minus infinite to 0, there was nothing, right? At t equals to 0, the ramp function started with a slope of 1. So it will start with a slope of 1. At t equals to 2, what will happen? So this is slope equals to 1. So at t equals to 2, what will happen? It will gain a slope of 1, right? So now from here it will turn. So now the slope will become 2. So and this is how it will go. Are you able to understand this or not?
So suppose here it is 2r into t minus 1, t minus 2.
2.
Suppose here it is rt plus 2r t
Hmm.
minus 2. Right? So the second point, the magnitude is 2 then.
Okay. So plus 2 t minus 2. Okay. You tell me what will happen. So it will start with slope equals to 1, right? At t equals to 2, it will gain a slope of 2, right? So it will be slope of 3. Okay.
Okay, sir. Okay, sir.
Have you understood? Huh. See, let's for example, you have a function xt equals to r of t plus 1 minus r of t minus 1. What should happen? So at t equals to 0, it should gain a slope of 1. Okay, it will start. At t equals to 1, sorry. So here it is t equals to minus 1 and here it is t equals to 1. From minus infinite till minus 1, correct? Till -1 there won't be anything. At t equals to -1, a line will start with a slope of 1, correct? At a slope of 1. So slope is equals to 1. Now at t equals to 1, what will happen? There will be a decline of slope of 1. So what will happen? What should happen? It should go like this, or like this, or like this. 1, 2, 3. How should it go? 1 or 2 or 3? Which one should I follow? 1
Slopes
or
negative,
2
then
or
it will
3?
go in the third part.
No, no. Earlier this line was having a slope of 1. Now, if I'll reduce a slope of 1,
Okay,
so
this
it
will
will be
go to
0,
two.
right? 1
Yeah, two.
minus 1. So it will go like this, correct?
Yeah.
So this will be the new signal for us. Is it clear to everyone?
Okay. Suppose if it is -2r.
Okay, no, next example. R of t plus 4 minus r of t minus 2. Now tell me. You can see that at t equals to -4, t equals to -2, t equals to 0, and t equals to 2. So at -4, it will gain a slope of 1, right? So it will start like this. Correct? Sorry, at -4. Okay? At -2, what will happen? It will go till slope of 1. Now what will happen? Can you please mute yourself? Okay. So now it will start. The slope is what? Slope is 1. Now at -2, what is happening? You're just losing. So slope. So everything you work in the form of a slope. In the ramp, in the unit step function, what you are doing? You are doing in the form of a magnitude. So you are adding and subtracting the magnitude. So this is the best, like the simplest way. You can do it in that way also. You just plot this r of t plus 4, r of t minus 2, and then do the addition, subtraction, all those things. You'll get the final version as the same one, but that will take a lot of time. Here, what we are going to do is at -4, the slope it gained is 1, right? So it started with y equals to x, something like that. Now at t equals to -2, what happens? It will lose that, right? -1, right? -1 is what? A line with slope of -1, right? So earlier it was slope of 1, so now slope of -1, so it will lose that slope. So now it will start, because plus and -1 will make the slope of this line as 0. It will be a parallel to x-axis. Till when? Till t equals to 0. Till t equals to 0, it will go like this. Now again at t equals to 1, earlier the slope was what? Slope is 0. Correct? Now it will gain a slope of 1. It will again start going like this.
1.
Again at t equals to 2, the slope reduced, right? Now again it will be the slope, earlier it was 1, so now again it will be 1 minus 1, so it will be 0. Is it clear or not to everyone?
Yes, I
All
understood.
clear.
Yes, sir.
Yes.
Clear to everyone, right?
Sir,
Okay.
one question.
Yeah.
Suppose where it is like here at last point x is equal to is minus r of t by 2, right? At last.
Hmm. Huh.
Suppose it is -2r of t by 2, then t minus 2, then.
-2 you are saying. -2.
Yes, sir. Yes, sir.
Okay, so now earlier the slope was 1, now the slope will be 1 of -2, so it will be -1, right? So it will go like this.
Okay, sir. Okay, sir.
Correct?
Okay,
Yeah.
sir.
Now in the same function, whatever you said, so let's for example it was, what was the value? Minus, right? Now what I'll do is I'll subtract minus 4 times u of, what will happen? Can somebody tell me? In the same function I subtracted u function, the unit step function, with a magnitude of -4. What will happen? So earlier the function was something like that. It was going something like that, right? There should be sudden change, right? There should be sudden decrease in the magnitude. Whatever the magnitude it was here, it should decrease, right? minus 4, the magnitude should decrease, right? This is what we have discussed, right, in the unit step
Yes,
function.
sir. Yes, sir. It will go down.
The function value will directly reduce, right? Whatever the value it was there. Let's for example here it was something a. So it will go down to what? A minus 4,
A
right?
minus 4. Yes.
And then it will start like this. So I hope this is making sense to you, everyone.
Yes, sir. Suppose if it is 4, minus 4 of t plus 4 means it will go left side, right?
T of
T plus 4 means it will go left side, right?
no t
Minus
plus 4.
4u
If you're
of t
writing,
plus.
you'll have to write it here, right? You have to write it here. So see, if
No,
you
no,
are
no. Like
plotting
I'm
a
asking.
yeah, correct, correct.
Yes, sir.
So
Yes, sir.
so you have to write in such a way that because you can't plot from right side, you can plot it, but if you're plotting it from left side, it's better you should not be missing any data. But like you can't be writing here, like you have just given an example, that's fine, but it's better if you it was t plus 4, you should have written here itself, so that both the operation you can do it in the starting itself. Are you
Okay, sir.
getting my point? Hmm.
Yes, sir. Yes, sir.
Yeah, so now let's for example I have a function x of t equals to ramp function minus 2 times t minus 1 plus r of t minus 2. What will happen now? At t equals to 0, t equals to 1, t equals to 2. What will happen? T equals to 0, the function will start like
It
this,
is
correct?
uh,
At slope equals to 1, right? At t equals to 1, the slope will be what? The slope will be
Minus
c.
1.
Minus
This
1.
is slope, correct. This is slope 0, and this should be slope minus 1. So it will follow the third path, correct? And it will go till what? It will go till t equals to 2. T equals to 2. So it will go like this. And now at t equals to 2, because it was slope was minus 1, it has gained one slope plus 1. So now it will start going like this. Everybody is convinced with this?
sir, please
Yes, sir.
explain
Are
once
there?
more.
Are you able to understand this? What?
So please explain this part again.
Okay. Huh. So what happens? This is the function. So I already told you ramp function. How does it work? So it works with a slope only. So now it started with t equals to 0. At t equals to 0, the slope was 1. So it has started with slope as 1. Correct? Now what happens? At t equals to 1, it should lose the slope of minus 2. As from the starting the slope was 1. So if you are just losing minus 2, like 2 if you are losing, so 1 minus 1 minus 2. Correct? Now the slope should be what? Minus 1. So it has started going down. Okay? At t equals to 2, now it has to gain a slope of 1. Okay? So as earlier it was slope of minus 1. If this value was not there, it would have gone like this. But as at t equals to 2, it has been said that it should gain a slope of 1. So earlier the slope was minus 1. Now it should gain a slope of 1. So 1 minus 1 plus 1. So now it will start going like this because this is the function where the slope is equals to 0. Are you getting me?
Yes, sir, understood.
Okay. Now, if you see this function, this is what? This is a triangular function or a triangular signal that you deal in the signal and system. Okay. Okay. Now I'll just give you some more example that you have to tell me. I will not be plotting so that it will be clear to you. So now r of t plus 2 minus r of t plus 1 plus 2 of ut plus r of t minus 3. How will I plot this? It should start with from where? At which point it should start?
Minus 2.
Minus 2.
So,
At t equals to minus 2. At t equals to minus 2, it should start as slope as
1.
Slope equals to minus 1. Sorry. Plus 1. Okay. Till t equals to minus 1. At t equals to minus 1, it will lose that slope, right? So it will start having a slope of 1 minus 1, 0. Till which point? Till here. At till u equals to
0.
till t equals to 0, correct? What will happen at t equals to 0?
There is
It should
increase
gain a slope of 2 or a magnitude of 2.
Magnitude of 2.
magnitude of 2.
Correct. So whatever the magnitude, let's for example, so magnitude also you'll have to calculate it. Okay, you can just think of, but that I'm not going because again it will be a confusing. Maybe in the coming session we'll see that how to calculate the slope also. That's not very difficult. You already know that this is the equation of a line. Okay, if it is coming with minus 1, okay, if it started with minus 2, right, at minus 1 the value will be 1. I hope this is just a line, like equation of the line, right? So it started with minus 2, slope was minus 1. At minus 1 the value is 1. It will go till t equals to 0. It should gain a magnitude of 2. So earlier it was 1, now it will gain a magnitude of 2, it will be 3. Correct? And it will go in with the slope of 0 only, because we have not changed the slope. We have just changed the magnitude. There is a jump at t equals to 0. But the slope doesn't change. The slope will change at what time? At t equals to 3. So at t equals to 3, the slope should change. And the slope should change at how? It should gain a slope of
1.
1, right?
1.
Okay, so it will go like this. Let's for example it was minus, then it would have gone like this, right? Because this is a slope as minus 1. If it was plus, then it would have gone like this. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. So now I'll just give you one more, and that will be the last. Okay, so this is simple. What will happen?
Yeah, all the points are same actually. The starting point is 0.
Magnitude is decreased.
What will happen?
The magnitude will be decreased.
Okay, see what will happen. It should have started like this, correct? It should have gone like this. But what we are doing, we are subtracting 2 magnitude for each of the point, right? This is what we are doing. So it should, so each value will be reduced. There will be a sudden change in each of the values of the RT, right? So this will start like this. This will go like this. Have you understood this? I hope you have not. Let's do it again. Okay. So what will happen? You have a RT function. RT function is what? This is how you present the RT function. Minus of, you will do a subtraction of 2. So each of the, oh, okay. So this is till here only. Now t less than 0, nothing will happen. From t, you can see that here the value was 0. Okay. Let's for example 0. Very small value at t 0 plus. Let's for example take 0 only. Now here at t equals to 0, here also it's not defined, but take 0 plus. So here 2. So 0 minus 2. So it should start from where? Something like that, right? Each of the value will get reduced to by 2 values, right? So it will go something like that. Are you able to understand this or not?
Yes, sir.
Okay,
The
so by
slope, what
default
is the
here
slope
we
of this
should
function?
must
What is the slope of this function? 1 only, right? Slope will be 1, right?
one
Only the
only, sir.
magnitude
One.
is getting reduced by 2. Correct.
Whenever the we have same points, that time we have to subtract the magnitude.
Correct. So two operation you are doing here. One operation is the slope is 1. and one thing is at t equals to 0 itself, two operation you are doing, right? Earlier what we are doing, we were having the different data, like at different time instant we are doing the different, either we are changing the slope or the magnitude. Now what we are doing, at the same instant we are doing two things, right? Slope, we are adding slope as 1 plus magnitude as -3. Sudden decrease in the value also, and the slope also we are changing. Are you getting me? If
Yes, sir.
I'm asking you to plot this RT plus UT, so two things are happening at a t equals to 0 itself. So from minus infinite to 0 there is nothing. Exactly at t equals to 0, when it comes, it has seen two functions. One is ramp function, one is the magnitude. So there should be an increase in the slope also, and plus there should be an increase in magnitude also. So now what will happen? You can see that at it should have started like this, but now what will happen, I should be gaining one magnitude also, so the gain of one magnitude plus the slope should be 1, so this should be the function. At t equals to 0 itself, two operation has been done. Are you getting my point or not?
I understood,
Yes,
sir.
sir.
Understood, right? Everyone understood this?
Yes, sir.
Yes, understood.
Okay.
Sir, one query, sir.
Mm-hmm.
Suppose magnitude are in decimal numbers, then like 0.5, 1/2, like that or not?
No, so zero point 0.5 will increase.
Oh no, by plotting. Okay, understood, sir.
Okay, if it was RT plus 0.5 times UT, nothing. Earlier we were adding 1 as a magnitude, now we'll add 0.5. Okay. Now I'll just go through the triangular function that was, or maybe the triangular and the signum in 10 minutes. So what happens? So triangular function we don't use much, but I'll just, when you'll be going through the Fourier and all, that you'll be dealing more with the triangular function. So triangular function is represented by a, same thing, t by tau. The only difference here is tau here is not the width. So in the rect function the tau was the width, right? So here 2 tau is the width. Okay, that's the only thing. So you'll be represented, so mathematically it is represented as a of 1 minus mod of t by tau, where t is from, like you can just take it as from minus tau by, or you can just write it as t is from t, or for other cases the value is 0. So it is represented like this. So the function, if you'll just see that, this is represented like this, minus tau to tau, and a is the maximum magnitude. So the width is what? 2 tau. So whenever the triangular function is represented like this, t is not the width, 2t is the width. Okay, that there can be confusion. So in the rect function, a of rect t by tau. So here tau was the width. So it started with minus tau by 2 to tau by 2. Here 2 tau is the width. Okay, that's the only difference. Like, even though the function totally is different, but I'm just telling you to not get the like, you should not be having the confusion. Rectangular function that you use, mostly you use the rectangular function. There everything is fine. Like tau is the width. In the triangular function, 2 tau is the width. Okay, clear? That means this is the half width. Is it clear to everyone?
Yes, sir.
So at least
Yes,
the
sir.
Yes, sir.
standard function you should be knowing. Nothing else. Standard again here also. If you'll see that the area will be what, 1 upon 2 times 2 tau into a. So area is a tau. Here also, whenever you have a function, triangular function with area as 1, that you call it as a unit triangular function. Okay, it's clear to everyone.
Yes, sir.
Yeah. So, and all the other thing that we have dealt, I guess everything clear. Like nobody has any doubt as of now. Like whatever we have discussed today. Is there any doubt anybody has? You can just ask me.
No, sir. No, sir.
No, right? So okay, so triangular. I'll just give you an idea. So this is how you present a triangular function. Nothing. We'll discuss more operation in the coming sessions. We'll have to start with the week 2 also. I was just discussing the standard function so that in the coming weeks you'll not be facing any issue. Okay, so signum function is also pretty simple. I told you in the form of a ut also, but it is represented like this: 1 for t greater than 0, -1 for t less than 0, and 0 for t equals to 0. So signum function is defined at t equals to 0. Okay, or in the, if you'll just see in the form of a Gibbs phenomena also, it is +1, -1. So if you'll take the average also, it will be 0. But even in other cases, like it is defined already. So at t equals to 0, the signum function value is 0 already. So at here it is 1, here it is -1. This is t, this signum function. Okay, so this you can write in the form of a ut also. You can write it as, we have already seen, right? Ut minus of u of minus t. This will be signum, right? You can see that this is ut minus of u of minus t. How will you represent u of minus t? Minus t. If you'll just subtract it, what will you get? From 0 to infinite, 0 minus 1. So minus 1. Okay, and from t equals to 0 to infinite, so my earlier from minus infinite to 0 it was 0 minus 1, and from t equals to 0 to infinite it is 1 minus 0. So this is the function, right? Is it clear? So this is your signum function. Can you write the signum function in any other way? Can you write in any other way? Can somebody tell me what is this? Is it a signum function or not? Is this a signum function or not?
Yes, sir. No, no, no.
Correct, right? If you just see
Yeah, ठीक है.
2 times
It's just a one.
2,
Yeah, it's fine.
yeah, 2 of ut minus of 1. So 1 is like this. So if you just from 0, if you just minus infinite to 0, 0 minus of minus 1, so it will be minus 1. 0 minus 0 minus 1, so it is minus 1. From here, from t equals to 0 to infinite, 2 minus 1, so it is 1. Correct? So this is also signal. So you can represent in other like way also. So this is what the signum function is. Others, I hope I have already discussed all the standard function, right? I guess the exponential function you have already read in the maths, so it's fine. So I'll just give you an idea. How do you represent e to the power at? Correct? And if you have to multiply, if you have to just represent from 0 to infinite, you can just multiply with ut. So now you'll be left with what? Like this: e to the power at ut. Correct? If you have to represent e to the power minus at ut, how will you represent?
Decaying like slope.
Correct, decaying. So if you multiply, you will be left with like this. This is e to the power minus 88. So I just gave you an idea about all the standard functions. So now you are already aware of all the standard function. Okay, operations also we have dealt with, scaling, shifting, and all we have already dealt with. I hope some of the problem also has been done by Srikant also in the previous session. So now we are done with the basics of the signals, right? Now we'll start with the week 2, okay, and then we'll go ahead. Okay, so we are done for the today. Have you understood everything? Any doubt that you have, you can just ask me now. I'm there. Or maybe you can put it on the discourse on the G space that you have created, or maybe you can mail me. So whatever you want to do, you can just ask it out wherever. Okay, you have you gone through the practice questions graded? Have you submitted the graded or not as of now?
Yes, sir.
Okay, practice the practice assignment. Any doubt, you can just put me like put the questions in the G space or discourse wherever you want to. Okay, or maybe in the coming session also you can discuss. But have you
So,
gone through? Have you tried solving each and every questions?
Sir, I have doubt in practice assignment question 2.
Okay, practice assignment. I'll have to open it.
Yeah.
Give me 1 minute just. Okay, so practice assignment, which question you said? Question number 2.
Question 2, yeah, yeah.
Okay, so what has been given? Let x be a signal. Okay, be a signal with x equals to 0 for t less than 3. Okay, now, okay, so what's the doubt here?
So how the value of t is like, how can we evaluate the value of t? I understood
Okay, xt has been given, be a
graph.
signal with uh, t less than 0. What is this? T less than 3, the value is 0. Okay, for which signal? For xt only, right? For let xt be a signal with xt equals to 0 for t less than 3. For the following signal, for the following signal, for which following for the following signal, determine the value of t for which it is guaranteed to be okay, okay, got it, to be 0. With the above data, kindly answers. Okay. So now, if you have to represent x of minus t plus 1, how will you represent? What did I say? You have to any function. Here it has been represented in the form of x of minus. Every time you represent in the form of mx plus c, first of all. So we have represented in this way. Now you start from, like, always use this method. Okay, do not use the forward backward both. So you'll get confused always. Always use the always propagate from the back side. Okay. So now, what is the first case? You'll have to shift left side or right side. So earlier the function was what? Are you there? Whoever has asked the question. Earlier the
Yes,
function was what? T equals to 3, right? 3. From 3 equals
yes.
to 3, it was 0, right? Now what will happen? The function should shift left side or right side?
Left side, sir.
Okay, left side should start. Okay, left side. Now after shifting left side, so first step is shift left side. So if you are shifting left side by 1 unit, correct? So everything will become minus 1. So all the axis value will be minus of 1, correct? Now the next step is what? T go minus t, right? What you are doing now?
Invert the function.
Time reversal, right? Time
Yeah,
reversal,
yeah.
correct? So now earlier it is t of 3, so minus 1. Now it is 2, right? So now if you'll reverse it, it will be t of minus 2, correct? So this is what has been
Yeah.
asked. So t greater than minus 2 will be 0. Got it, right?
Yes, sir. Yes, sir.
Yeah. So I don't think so. That was okay, but it's fine. Maybe you'd have got confused how the question is represented. Maybe
Yeah, yeah, yeah.
that might be a reason, but otherwise, there's no difficulty in understanding it.
Yeah, okay. Thank you, sir.
Okay. Thanks. Thanks everyone. Then any other
So,
doubt that you have? Anything?
so
Yeah.
one doubt I have, like, there is like a graph given like x is equals to t, x of t, like a step function, uh, just ramp function
Huh.
up to one, and then it's just dropped and it's zero further. Okay, so from zero
Tell
to
me.
one,
The
it's a
function
ramp
is
function. 0 to 1, it's a ramp function,
okay. 0 to 1. It's a ramp function.
and then it's zero all the way.
Okay. So this function you can just,
Zero,
so let's, for
not
example, this is t naught.
it's sir, it's a one, not.
Okay.
Yeah, I need zero.
Anything you can take. I was just taking t equals to
Yeah,
1.
no
Then
problem.
what is there?
I have
Okay.
a
And then
question, like we have transformed this thing, like we have scaled this thing or we have shifted it. Then we have to find the equation for it. So we have to find
see.
the
Oh,
like compare with the cx of at plus b.
no problem. No
Then I
problem. See,
have
this is
confusion
xt,
in
right?
finding a.
No problem. See, this is xt, right? How will you write this function? Rt. Okay. Now what you are doing? You are, the earlier the slope was 1. Now you are reducing the slope, right? So minus of r
Yes,
of t minus 1. Some correct? Now
Yes.
whatever you want to do, you can do shifting, scaling. What you already have this function, right?
In graph, I can
Which
do,
question
but
is this?
it was from week 2, lecture 1. So,
Okay, we'll discuss that in the coming session, but I don't think so there will be any issue. I don't know the whether what is the question, but okay.
actually,
So
I
that
have no problem in the graph, but I have problem in finding with the equation.
finding with
With the equation, like we have to find A and B. B, I know. A,
no.
I'm little confused,
Okay,
like V1 by V1 minus V naught divided by T1 minus T naught. So,
okay, no problem. So what you can do is put the screenshot of that question in the G space, or maybe on
okay,
the
sir.
Discord. Huh?
Okay.
Is that possible? Because
Yeah, yeah.
I can't understand that. Like I
Okay,
can do
okay.
it, but I can't understand. Yeah.
Okay, fine.
Okay.
Thank you,
Or
sir.
maybe you can just mail me. Anything is fine. No problem in that, right?
Okay, sir.
So, yeah, for any other questions also, anybody has any doubt at any particular time, you can just put it on the GSpace or Discourse. Okay, we'll try to solve it as then and there itself. Or maybe you can just come in the live session also. I have not for week 1, it was week 1, so I thought of discussing all the basic part. From the coming weeks, we'll be taking one session as a doubt only, where you can just, we'll just discuss the doubt. So it was just a week 1, so we've just uh, discussed about the basics, so that it was just an ingredient of whatever we are going to cook for the coming 10-12 weeks. Okay, so now you have that basic understanding of the signal shifting, scaling, reversal, all those things. So now you can will deal with whatever. uh, Week 2 also will be having one session just for the doubt itself. Okay, one session will be just summarize all the concept, one will be solving some of the problem, and one will be a doubt session. I hope that will be working fine with you all guys, right? Okay,
Okay, okay, sir.
so okay, thank you, then we'll just close it off. I
Thank
Was
you,
the
sir.
session helpful?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you, sir.
Yes, sir.
Okay, okay, then
Thank you,
then
sir.
we'll, yeah, thanks everyone for joining.
Thank
We'll
you,
meet.
sir.
Yeah, thank
Thank
you,
you, sir.
thank you. Yeah, okay.